Great. Okay, let's get started. Today, we're going to talk about game theory. Now, before I begin and I go on blabbering about what game theory is, what are different complex concepts in game theory, let me ask you, when you hear game theory, or if someone's already read about it, whatever, what do you know about game theory right now? Anything? Or what do you think about what is the sort of impression you get when people tell you, okay, look, game theory? Anyone, please answer.
I have never heard it before, but I'm just taking a guess.
Mhm.
Uh, is it related to like strategies based on probability?
Okay, good answer, Shivani. Other people?
I think it's kind of a mathematical strategy to calculate things,
To calculate?
to calculate different things like um, decision making
Mm-hmm.
of a person based on like mathematical expression deciding the deciding factor of a person regarding purchasing a product or something.
Fair enough, and I think you've got all the keywords right. I mean, this is a class on decision theory, so um, it does become about decision making. So that's cool, and you've got a lot of keywords right. So okay, anything someone wants to add on to the definitions we've got from Shivangi and Shivani? Give it a try, guys. No one? All right. Okay, so doesn't matter. It's fine. So the keywords, etc., that we got are absolutely right. It is about mathematics. It's about strategic decision making. Um, it is about probability, and it's about how, in different circumstances, you can calculate the different decisions you should be taking. So that's a very layman definition of game theory, but it does encompass its essence. Okay, right. So before I go on to what game theory is definitionally, where did it start from? And John von Neumann and Oscar Morgenstern, they've been really, really big in consumer theory, in decision theory, and in game theory as well. And they have frameworks that are very complex. So there's a Morgenstern Neumann von Neumann Morgenstern framework as well, which is an entire mathematical model for calculating utility and that sort of thing. So when you read, and if you do read up upon John von Neumann and Oscar Morgenstern, they've been very, very monumental, and they've sort of made the foundation for different things. Of course, I mean, they published Theory of Games in Economic Behavior in 1944, but since their game theories, examples for game theories, even for their other research work that's now widely accepted in the discipline, they've all been built upon and modified, but these people form the core. So I'm in college, right? And for me also, I will be studying about the Newman and Morgenstern frameworks, and they're that important and they form the core. Okay, but why we're not just having a class on Morgenstern and Newman is because of the fact that it's very complex math, and it's just math about it. So they were this is the generation of economists where economics turned from political economy, like political economics, to mathematical economics. So um, people before 18, I mean, I don't remember the time frame, but from Paul Samuelson, from John von Neumann and Morgenstern, Arrow and DeBrew, what happened with this generation of economists is that they started adding numbers and calculations and functions into calculating utilities and that sort of stuff. And before that, economics was referred to as political economy, and it used to be a lot about the politics, the socio-political scenarios, the abstract philosophy of economics and of humans as economic agents. So it's also very important to know the sort of generation or the age in which economists come, what is the context in which economists come in, right? Because the political scenario is what impacts their research work. But anyway, so they're the ones who began this entire idea of game theory, right? Now, why should we even discuss game theory? And that's exactly because of a lot of keywords that come about in game theory. And what happens is, so examples that we do right now, or examples that are prevalent in game theory, are are scenarios or simulations, right? But we gave you a form, and we'll discuss that form because your responses are whatever strategies you used to interact to a particular situation, right? And if you were there in the last class, we spoke about decision making uncertainty and decision making under risk. So here you're making decisions under uncertainty in the sense that you don't know what the other player would be deciding. And we'll discuss all of that later, so I don't want to get distracted. But why do you think game theory is so important? It's an entire discipline, it's huge, and it's ever increasing, right? And it's a very valued um, sort of concept in economic theory. So people who can interpret, understand, and calculate strategies on the basis of principles of game theory I mean, it's a really respected sort of expertise to have. Why do you think that is so? Why do you think game theory is important to study? Anyone?
I think I don't know. Does it like strengthen communication? Like you will understand what another person is thinking. So I think you will be able to relate to talk to them based on calculating certain outcomes. I don't know.
No, no, that's a fair answer. Anyone else? We've already discussed keywords, guys, so it should be rather intuitive for you to place those keywords in real life scenarios. Okay, have something in the chat. To calculate different outcomes. What kind of different outcomes?
Um,
Can I try this?
Yeah, yeah,
Like
please.
this is the outcomes that a consumer might take. Like for example, um,
Yeah, Shivangi, you're on mute now.
for example, the outcomes of a particular consumer, what a decision are going to take in a particular situation that can we can calculate through this game theory. Um, this is all about game theory. Decision theory basically. Game theory is all about decision theory, the decision making process a consumer does. Like we calculate that in form of mathematical expressions.
Yes, that's essentially what game theory is. And why it's important to study game theory is because as consumers, we are required to take a lot of different decisions in different scenarios. That's exactly why game theory is important. And it's another idea of where economics is telling us that use these mathematical models to take decisions that will maximize your utility. Okay, and that's also something we'll discuss. But it's important because of these components, that it ensures that you are taking decisions and you can model. So consumer decision making can be modeled using game theory frameworks. Decisions that are taken by producers, right, which is where game theory is very prevalent, that's also something that's very important and that game theory can help justify. If let's say you are increasing prices and your competitor has to decide whether okay, Ananya has increased prices for her commodities, should I also increase prices? This is a game theory question. Why? Because it's strategic decision making based on different actors. Let me go on to this. Wait a second. Yeah. Yeah. So defining game theory. So most of you guys have given me, the sort of keywords for decision theory. But also let's talk for game theory. But let's also talk about the components of game theory. Okay. So game theory is built up as a framework where there are different players. Okay, so people who are economic agents, right? I am taking a decision, and let's say Shivangi is taking a decision, okay? And we are in the same scenario. So, like we gave you an example of um, the exam case, and you've been caught cheating, right? So then you and your friend become the economic agents in this scenario, and game theory refers to you guys as players, okay? The payoff is what you will win or lose in these scenarios. So like if you confess, then you get this amount of punishment. If you don't confess, then you get this amount of punishment. These are your payoffs, right? Imagine this in scenarios where you're talking about producers, and the debate is between to increase prices or not increase prices. So then you're calculating payoffs on the basis of what would be, let's say, the loss to revenue if I increase prices, or what would be the gain in the number of customers if I reduce my prices. Okay, that sort of stuff. So that helps. And because all of these are naturally calculated in the sense of payoffs, because since the beginning we've been talking about utility and maximizing utility. So in all scenarios, if you're calculating payoffs in monetary terms or as time, okay, or as effort, punishment, whatever, it allows you to make a framework where you can choose a strategy or a decision where you can maximize the payoff you're getting. Which brings us to the third point, that is the decision making process or the decision that you take. So, the decision you take is the strategy you chose. And the decision making process of weighing in whether I should confess or not confess are the different strategies that are available to you. Okay, so the game theory definition technically becomes it's a study of way in which economic agents interact with the different choices and they produce different outcomes with respect to the preferences of those agents. So if I am Shivangi and I are interacting as economic agents in the scenario where we were caught cheating, right? And then the outcomes that I choose or Shivangi chooses will be based on our preferences, and they have to be chosen in a manner that maximizes my utility at least. And for Shivangi, she has to work in a manner that maximizes her utility. So choosing a strategy that maximizes your utility. Why is it coming? Okay. Another thing that I want to say before we move on to the survey is this idea that there are payoff matrices, okay, which is what we'll do. So you have payoffs, but you're creating an entire framework where you make value judgments and you compare different scenarios. All right. And that's important because that's the modeling part of game theory. And that's very important to understand. So I'll go very slow with respect to this, and you let me know if there are any questions. Okay. Okay, the game theory activity, right? This is the form that we circulated for everyone. Let's read it out, right, and break it down. You and your classmate are were caught cheating in school during an examinations. Okay, now what happens is that you have three scenarios essentially. First, if neither of you confess, then you're both suspended for 5 days. Okay. Second is if one confesses but the other doesn't, the teacher lets the person go who snitched. Okay, so they get, you know how in court cases or whatever, you can get a lower punishment just because you helped the police, that sort of thing. So that's why it's called prisoner's dilemma. We'll talk about that also. So if you confess but the other person doesn't, then the teacher who snitches the lets go of the person who snitched, and the other person gets kicked out of school. So it's the most severe punishment, right? Because you're ratting out on the other person. The third option is if both of you are confessing, right? Then both of you are suspended for 2 months. So it's a reduced punishment than one person snitching on the other, but it's still a greater punishment if neither of you confess. Because if neither of you confess, then essentially the principal can't hold you guilty, that sort of stuff. So this is how the scenario is modeled, right? Game theory is a lot of situational things, and see, if you see here and if you've attended the last class, you'll realize how decision making and uncertainty, how game theory relates to decision making and uncertainty. This is an uncertain environment because you are your own actor and you can only take the decision that you think would be right, whether to confess or not to confess, but you don't know what the other person is simultaneously choosing, right? So in the different categorizations that are there for game theories and the simulations and examples in game theory, this particular example, prisoner's dilemma, is essentially the most preliminary one. So if you search up game theory, prisoner's dilemma and zero sum games are the first examples that you get, because they're the most foundational in the logic. Okay. The second thing is that these type of cases are called simultaneous games. Why is it called a simultaneous game? Because both Shivangi and I are taking our decision at the same time. Okay, I'm in another room, Shivangi is in another room, and we have to decide whether to confess or not to confess simultaneously. So it's not a one move game, another type of games, which is where I have taken a decision and then Shivangi has to take a decision. So then in that scenario, Shivangi's decision will be based on the decision that I took. But here we are both acting as independent agents. All right, is that clear? Just
Yes.
yeah, yes, yeah, okay.
That's clear.
Okay, so they're different. I mean, these are again just two types of. There are multiple types of games that are modeled. Okay, so there are games actually which talk about a war scenario. So imagine the two economic agents are two countries. Okay, and you have to take a decision whether it makes sense to get into a war. Okay, and then that is something that can be modeled using game theory moves. And you say, okay, be threatened. Now, should you attack? Is that giving you a greater payoff? If you're not attacking and you're just threatening, what would the other country do? Entire thing, it's very cool, and there's an entire YouTube series on this also. I mean, that's what I refer to when I was trying to read up more on game theory, and it's very comprehensive, and it talks about all of these cases as well as the actual mathematical calculation of payoffs. Okay, because that's something we won't be doing here, because um again, I think it would get too complex for the purposes of this class. Okay, now this is the scenario. You wait a second, this something in the may I know the name of the series? We'll send the link with the resources that we provide. Okay, so all of you can refer to it, and I'll probably like send the link on the group. That should work. Okay, yeah. So let's talk about survey responses. So what is, we sent out the survey, 9 people responded. What was the general consensus? To confess. Is there anyone here who said not? Sorry, the general consensus is not confess. Is there anyone who's here and who had actually responded confess in this survey? No one? Okay. Which is, sorry?
May you repeat the question?
The question is, what did you respond? Is there anyone here who responded confess to this question? Because I mean, we only have 5 people in participants and we got 9 responses. So I was just wondering if there's someone here who's actually responded confess. Seems like none, no worries. These responses are very interesting. Like I thoroughly enjoyed seeing this. Okay, now what we'll do is we're breaking down the scenarios. Okay, so A and B are our two economic agents. Now what we're doing is, what happens that what we're doing is the punishment, we're providing a numeric value to it, because that helps us calculate the different payoffs, right? And it can help us provide, let's say, so how much would a 5 day or a week suspension hurt me versus how much would a 2 month long suspension hurt me. So what we've done is we've just provided notational numeric values to these suspension dates. All right. Now for A and B, we have neither confesses. What happens in the scenario when neither confesses? The principal gives them a week long, or I think it's a week long. Only suspended for 5 days. Okay. So they're only suspended for 5 days. So notationally, we've made it a 5 and a 5. Okay. Now the next scenario is A confesses and B denies. Okay. Now in that scenario, what is happening is I am let off and the other person is kicked out of school. Okay, so if A is confessing or snitching on the other person, then the person is let off, so their sort of negative pain becomes a zero, and the other person is getting kicked out of school, which we provide like an infinite value of uh, pain. Okay, the other scenario then becomes A denies and B confesses, so the options are reversed. Then both confess becomes a 60-60, which is that both of them are suspended for 2 months. All right, is this sort of what we've done? Is we've taken the situation we got and we've broken it down into numbers and a matrix. Does is this making sense for everyone? And only then I'll move on.
Yeah.
Yeah, makes sense.
Okay. Now, what happens here? Now we've made it into this becomes a payoff matrix. So this is like a simple table where we've sort of corresponded all the values, right? But this is not the format of a payoff matrix. This is the format of a payoff matrix. Like you have player one on the x-axis, player y on the uh, y-axis, right? Or it can be player one and two, the horizontal and the vertical, that sort of stuff. But essentially, this is how you model. And what you've done is you've modeled all the four scenarios that are there. If A is confessing and B is confessing, a 60-60. If A is denying, B is denying, a 5-5. Confess, deny, deny, confess. You've modeled all of these scenarios in this payoff matrix. And this is much, much neater, right? From the wordy paragraph that we saw earlier. And this is where we'll do the bulk of our analysis. Okay, now that we have this matrix here, what would you decide? What should you choose?
According to me, we should choose, like, the person should choose neither to confess, or if someone is confessing, you should, like, both should confess, because if both the things are happening, each of them are getting the same amount of punishment, like same amount, like it is not same from both of them. According to me, we should do that.
But which one, Vidya? We have to choose only one, right?
So here the
Right,
problem is that two people are in two different rooms, so they don't know what the other person is deciding to do. So I had chose not to confess, but now I guess I should have confessed it because, like, I am on the safe side for that.
But if both of you don't confess, then you're at a
Yeah.
fight.
Yes, but the other person may also confess for that. We don't know what the other person is deciding, right?
Okay, good one. Other people, what do you think?
I would choose not to confess. I actually chose not to confess because the punishment is lesser,
Mm-hmm.
and if we consider other factors like class unity and because when you cheat, you have a pact that if you get caught, you would deny it. So taking that into consideration, I chose not to confess.
But okay,
Like
okay,
other
then
agents.
hold on to that idea that there are other things like class unity that might impact the decisions you make. Because okay guys, what is the first assumption that we started off with when we started off this class, and about what does classical economics assume about how economic agents react? What is the characteristic of economic agents in classical economics?
Maximizing the utility, like maximize satisfaction.
And the other, there's one more.
Monotonic preferences are more the better.
Yeah, and also the fact that economic theory assumes that you are always rational, and rationality is something that is in their sense something that can be mathematically modeled, right? So rationality is something which will have a logical answer. So whatever Huang said about that class unity could come into picture, or the fact that you have a pact with the person you're cheating with, I'll bring this up because it's adding on a human element and a qualitative element to a quantitative problem. Okay, and here what you have to take, the way game theory works, since it's also a part of conventional economics, right, and something we're developing on and simultaneously questioning. So given that, you know that at least I am rational, and it is fair to assume that the person who's sitting in the other room is also a rational economic agent who would want to maximize their utility, right? And the problem here is that you're being punished in all scenarios. The only trade-off is whether you confess, not to confess, because that will result in a difference in the punishment that you're getting, the level of punishment. And the severity of punishment is something worth considering for, right? A 5 day, 1 second. A 5 day suspension is not the same as a 2 month long suspension from school. Okay, so again, I've set down the foundations. Now tell me, what should we do?
I think I chose not to confess, and I think I'll still stick to the option.
Okay, Shivani, what's your favorite color?
I don't know, purple.
Let's see if we have purple. Okay, Shivani has chosen not to confess, right? So is it the 551?
Yeah.
Yes.
Okay, who else? Let's see what everyone here is responding.
I would also stick with not to confess, the 5-5
And
one.
what's your favorite color?
I would go blue.
Blue, we have a nice blue. Quack has also chosen 5-5. Okay, Angel, what about you?
Probably the same as everybody else.
No, you have to. So what is everyone else choosing? Deny, deny?
Yeah, deny, deny.
All right, and why are you choosing that?
It's because I don't think the benefits of confessing will outweigh like the harms of going through that.
Okay. And you're considering all the assumptions that we discussed?
Yeah.
Okay. All right. What's your favorite color?
I'll go with green.
So we have 3 people at 5-5. Damn. Shivangi, what about you?
I'll go with confess, confess.
Okay. What color?
Pink.
We have one confess, confess. Interesting. Vidya?
I will go with deny, deny.
And what color for you?
Black.
Lovely. Okay, so we have Saima and Kritika Ref. Guys, what are your responses?
I'd go with confess, confess.
Kritika will go with confess, confess. What color?
Red.
Okay. And Saima. Sorry.
Deny, deny.
Okay, what color?
Yellow.
Okay, then the majority has again chosen deny, deny. And now it might be a bummer to. Okay, let's explain. So everyone chose deny, deny because it was reducing the pain for both the economic agents. Am I right? Is that the
Yes.
yes? All right. Now, if I am player A, okay, let me change this. Something cool. If I am player A, okay, then I choose to deny. That's a 5 for me, right? But I also have to think about what the other person will react, right? Because if I deny, but the other person confesses, then I get kicked out of school, correct?
Yeah.
So, what happens when I deny, but the other person confesses? So, I deny. So then we shift from this scenario to this scenario here. So I denied, but the other person confessed. It'll actually be the opposite way. This is A for me. So this becomes my pain if I am denying, but the other person is confessing, because the other person is let off and I get kicked out of school, right?
Yeah.
Okay, let's take the other scenario. I'm player B. Okay, now I choose to deny, okay, but I don't know what the other person will do. For the other person, I have to compare this 5 to this infinite, right?
Yeah.
So if I choose to confess, sorry, yeah, if I am denying, okay, and then I choose to confess, what am I doing? Let me, yeah, if I am denying and then I choose to confess, then player A gets an infinite pain. Is that right?
Yes.
And the similar thing is holding true here. If let's say I deny, player A confesses, I get infinite. If player A denies and I confess, player A gets infinite, correct?
Yes.
So do you think that if economic agents are maximizing, player A or B will choose to deny when they don't know what the other person might choose simultaneously, and it might lead to an infinite thing for both?
Yeah. Now that I think of it, I don't think they'll be choosing to not confess.
And why is that?
Because just as I said, based on the risk that they're going to be taking, if you're going to choose deny, it's either a full-on suspension for you and a scot-free option for another. So uh, I don't know the analysis which you did. I just felt that that was right. Not sure.
That's completely cool. We're here to question how you respond, right? And that's what we've done since the beginning of the class anyway. Anyone else who would now want to change their response? Now that I've said that it leaves a space for change, or that there is a different way that the person could minimize the pain, right? Player would want to confess because 5 is more painful than a 0. Similarly, player B would want to change to confess because 5 is more painful than a 0 here. So, do you still choose deny, or do you choose confess?
Deny.
Deny.
Because I want to explain my decision, because according to me, those two students are friends, like they are classmates. So like if they're cheating, they have done something, like they have talked before or they have done it mutually. So like they have an understanding that if they are caught, they won't, like it's all about my theory. So like according to me, they won't confess. Like both of them will have that willpower or that strength, core strength to not confess and to like adhere the 5-day suspension.
Okay, but don't you think that, Gia, do you want to say something?
Yeah, I actually wanted to respond to that. So if you see in the question, I think it was mentioned that it was explicitly mentioned that you're not friends with that person. So I feel like if you take the deny situation and separate, since especially since you're separated in two rooms and stuff, you have no way to communicate with each other. For example, if it's me and my friend, now isn't it much safer for me to take the bigger punishment than deny, which is confess? Because if I take deny, then I'm in a position where if that person just changes his stance a little, I don't know, some sort of moral compass comes upon that person and he decides to go all like, I'm going to be truthful and all, then I get expelled from school. And that's a huge deal. So wouldn't I want to be safe, especially considering that person is not my friend, since it's mentioned in the question like that?
I completely agree with Gia because it was mentioned very well that we were not friends, we were just classmates, and we are in two different rooms, so we don't know what the other person deciding, and it's better to like get a 2 month suspension than to get expelled from school.
Thank you for that rationale. Anyone else who now wants to flip?
I think I'll flip.
Okay, we flipped Shivani, good one.
Yeah.
Anyone else? And if you're not flipping, then we again need reasoning for that.
I will also flip. Yeah, I will also.
Vidya. If you're not convinced, right, about what we're doing here, you ask. And we'll tell you why confess seems like the better option. Come on, guys.
But like there's a huge risk that if that other person also confesses, you both have that suspension of 2 months. So like that's also one huge risk. Like,
But isn't that punishment much less than being expelled from school? It is a huge risk given. Of course, it is a huge risk. I mean, 2 months suspension is a big deal. But being expelled from school is much worse, right? And you wouldn't want to risk that.
What is the trade-off? Please, it's economics is going to be all about trade-offs, and this is a payoff matrix. This is exactly what we do. But you have to choose a scenario which is stable. That is, that if both of you, why did I revise the assumptions that we work with in economics? That you're rational agents, you have to maximize your own utility, right? Which means that if I am a rational agent, then even if the option was between deny and deny, right? You're saying that as player A, I should deny. Okay, then I still have no idea about what player B will do, right? And for player B, if I compare between deny or deny and confess, right? Then for player B, it's much less painful if player B confesses. So then I've actually taken a decision which is putting me in a situation where I could get kicked out from school, because I don't know what the other person might decide, but I do know that if I'm a rational agent, the other person is also a rational agent, which means both of us are working to maximize the utility and minimize the total punishment we get. Anyone else who's flipping? Okay. Let's talk about equilibriums. Okay, maybe that will help in the confusion that you have in your head right now. What do you guys understand by equilibriums? Simple.
Like the two constants are equal, like demand and supply equal, that is the equilibrium for demand, like that.
Okay, so what does it mean? What is the state of equilibrium?
I
Well, I
think
don't.
when yeah, go on, go on.
Like, I'm not sure, Shivani, go on.
Okay. I was about to say when sides of an argument are balanced.
Yes, so essentially it is equilibrium is defined in a situation where you reach a certain situation where none of the actors have any incentive to change their position. So it's a state of rest. Okay, it's a place where if you've chosen this decision, you won't be choosing to take any other decision given any other circumstance. All right, that's why it's a state of equilibrium. If I've chosen this, then this is a situation, this is a circumstance which is maximizing the utility for both of them. In demand and supply, the example that Shivani gave, when demand and supply become equal, it's called a state of equilibrium, because that is a spot where neither demand would shift, neither supply would shift. It's the perfect spot, right? Now, in this scenario, do you think that, and the pursuit in economics is to find equilibrium? Okay, so then here, do you think that there is equilibrium when player A and player B choose deny? Or does any agent in this scenario have an incentive to shift the responses?
If you take deny, I think under that you will have the chances of shifting responses. So I don't think it's an equilibrium option.
Okay. But when I said that, let's say I have chosen, I'm player A, I've chosen deny. Okay. This is player B's payoff. This is player B's payoff. If I choose deny and player B chooses confess, isn't that reducing the pain that player B gets? So wouldn't player B naturally want to choose from deny to confess deny?
Ananya, could I add something over here?
Yeah, sure.
Okay, so what we want in this particular payoff matrix is for us to have the lowest number of days, right? So when I'm in the deny situation, if I'm player A, for example, which is the first digit, I can't go any less than 5. Therefore, that is a good situation for me. Deny is a better situation for me than confess, if you see it right here. Sorry, I'm talking about player A. Sorry, what was I saying? So if player B denies, then it's better for me to confess, because then I'll shift to this side, because if 0 is less than 5. But on the other side, if it's player B, then I would want to shift from 5 to 0. That is mean from deny to confess. If I wanted to shift from, say, deny to if I wanted to shift from confess to deny, then I'd be shifting from 0 to 5 in the case that player A is denying. That means I'm getting more days, so I wouldn't want that. Does that make sense?
Would it be a stable equilibrium if there are situations where you could reduce the pain that you're getting? Guys, you have to respond in case there's any question. For both A and B, right, isn't choosing to confess here. Okay, for player A choosing to confess, making their payoff a 0, and for player B choosing to confess, isn't that making their payoff a 0?
Can you repeat your question once?
My question is the same, which is that is 5-5 an equilibrium? And if not, then you know what the answer should be. Whatever payoff decision, the strategy that you choose, it has to be an equilibrium strategy. So it has to be a strategy where no agents have any incentive to change the move. Okay. So the question is 5-5 an equilibrium position? Where I can see that A also has incentive to change, confess and make their payoff 0, and B also has incentive to change and make their payoff 0.
Yeah, I think so.
What?
Me too. I think
The what is
so that like it's an equilibrium situation because both have the chance to change.
So it's not an equilibrium position. No, equilibrium position is a state of rest. You shouldn't have the chance to change in an equilibrium position. Are you understanding?
Oh yeah, okay.
When if you've done supply and demand, right? I feel like most people might understand from there. Supply and demand. When we say supply is more, then you say that okay, demand will increase or the prices will increase until they again become the same point. And that same point is a position where neither demand shifts from, neither supply shifts from. It's a state of rest. So that the other economic agents should have no incentive to change from that position. But here what we are seeing is deny scenario, right? Player A has incentive to change, confess, and make their payoff a 0. And player B has incentive to change, confess, and make their payoff 0. So then can we say that 5-5 is an equilibrium position?
No.
No. What is the other position that seems like an equilibrium position?
I think
Confess.
Yeah, confess.
Exactly. And it seems difficult to understand. I get that. And it's difficult for us to also understand when we do it for the first time, right? But the reason why confess wins is because now if player A chooses to deny, then they get an infinite pain. If player B chooses to deny, they get infinite pain. And so this is a scenario. If I'm working with the assumption that economic agents are rational and they choose to maximize their own utility, and obviously from that, the corollary is that you choose to minimize the pain or the risk that you're subjected to. And so if Gia and I both understand game theory and both understand that this is a payoff that will maximize us, given the fact that we are not friends, we don't have a pact, there's no social contract between us that will say that irrespective of what happens, we will not confess. Okay? Because economics doesn't assume society when it's talking about game theory. So it's not taking into account all of these social or psychological factors that we've discussed. And I feel like those might be reasons why you were like most of the people were more convinced towards the deny. Because even though it is minimizing the punishment for everyone, what it's doing is it's leaving you open for damages. Because if the other person is rational, they'll choose to confess and snitch against you because they let go freely. And if both of you choose to confess, which seems like the rational option for both of you, then both of you get 2 months of suspension. But that 2 months is still less than being kicked out of school. Now, is it making sense?
Yeah, yes.
Any other questions with respect to this? Nothing? Okay. This was the most. Do we have something in the chat? No, okay. This is prisoner's dilemma. Now, the scenario that prisoner's dilemma takes is that you're caught, but you're robbers or whatever, and you've been asked that if you confess, then you get a certain months of prison time, and the other person gets less, or you get sent into prison for 2 to 3 years, and the other person also gets prison for 2 to 3 years. That sort of scenario. So this is exactly the same, just that we've made it a cheating case rather than a prisoner's dilemma case. And you might have seen it happening in movies a lot of times, right? You put in two prisoners and you wait for one person to crack and open up and confess. So it's a good thing that now you know game theory. So you know what would be the maximizing utility decision. And it's a strategic decision, right? We had to synthesize, break up the entire paragraph, make it into numbers, and decide what is a scenario, a strategy that will maximize my utility. Because player A is going to take that decision simultaneously. It's not like I know that player A is going to confess and then I can choose to confess. Or that I know that player A is going to deny, so I should now confess because that will minimize my pain. You're taking decisions simultaneously. So this entire conversion from 5-5 to a to a 0 infinite to a 60-60, this entire mechanism, this decision making process is something both of you are doing simultaneously. So you're taking the decision to maximize your utility simultaneously. And so a 60-60, which is a confess, is a decision that economically rational agents would take. Is that cool for everyone?
Yeah, that's clear.
Okay. So it's extremely interesting, and this is the beginning of game theory. And this is literally the easiest simulation that we could take up because it's fairly, in comparison, it's easier to understand. And as you go on, it's very intuitive, but also makes you question everything. Because everyone here chose deny, and we had to analyze and interpret and break down our ideas to see why confess is a economically better response. Okay, this is why. Now you see what people did and why it's so interesting to see. Everyone, 77.8% choose not confess. That's why I was also asking if we have people here who chose confess here, because it would have been interesting to see their rationale, and because we only asked what you would do, so you had no idea what your friend might end up doing. And you have to take that into account when you're working with different economic agents, right? We're talking about two people here. What if there were more people? Okay, having a 4x4 matrix where you have to see what other people will decide, rule out decisions on the basis of that, okay, this is increasing the pain that I'm getting, and then come to a decision, come to an equilibrium that will satisfy the needs for everyone and ensure that there's no change beyond that. Okay, so this is essentially the original prisoner's dilemma matrix that's essentially made. So you can keep quiet or confess. Confess has a less punishment than one person confessing and the other person keeping quiet. And keeping quiet again has, both of them keeping quiet again has the least pain payoff essentially, but yet confess becomes the equilibrium spot. And so I've spoken about equilibrium a lot. And what is equilibrium for game theory? And John Nash was the economist who developed this idea of where in economic theory or where in game theory you can decide that there's an equilibrium in this particular payoff, right? And there's actually a movie on John Nash. It's the name of the movie is The Beautiful Mind or A Beautiful Mind. It's by John Nash, and um, he's the only person who's won, I think, a Nobel Prize for economics as well as for no, he's won an economic prize for two fields. So I can't remember the other field. I think it's one of the sciences, maybe physics, chemistry, or something. But pretty cool guy, and Beautiful Mind is also a great movie. So what he says is that you have to choose a strategy where players cannot improve their payoff independently by changing the strategy. So what was happening in the 5-5 scenario is that one person could shift their strategy to a confess deny, and that will reduce the pain and therefore improve the payoff, right? Improving the payoff is naturally termed as a positive thing. Currently we're working in a negative thing, which is a pain matrix essentially, right? So a Nash equilibrium is only where you're arriving at a strategy or a point where none of the players have any incentive to change their strategy, and that's called a Nash equilibrium. So this is the terminology used for equilibriums in game theory. Okay, and there are a lot of games which actually can't find a Nash equilibrium, and so there are different strategies or different strategies and scenarios where you see that you're only calculating the maximum thing. So let's say here we did a 5-5. There will be where you're taking 5-5 as the payoffs, and then the probability that a person will choose deny. So 5 into 1 by 4 plus a 5 into 1 by 4. So you're also calculating payoffs in a numeric term, and then you provide values to each decision, and then you decide what is the decision that is providing you with a greater payoff in a numerical sense. So when you've done a payoff into the probability of that strategy being chosen. So that's again advanced game theory, right? So Nash equilibrium, this means that it's the best strategy assuming that the other person will also choose a strategy that is maximizing their utility. So you're finding an equilibrium again. And so we come back to the assumptions we started off with. Now, different varieties of strategies, right? And there's an entire literature for the theoretical and the technical terms for strategies. The one that corresponds to prisoner's dilemma is dominant strategies. That is, that it is the best outcome irrespective of what the other player chooses. Okay, so irrespective of what A does, you should choose B. You should choose to confess. Okay, and so there are weakly dominant strategies as well. Let's go back to here. Okay, player A and player B. If I am player A and I'm choosing to deny, okay, then I have a 0. Yeah, if I am player A and I'm choosing to deny, but the player B is confessing, then I have an infinite. Okay, so then I compare the infinite with the 60, where I confess and player B also confesses. Okay, so between infinite and 60, I choose 60. Okay, then if let's say I am choosing to confess and deny, but player B is denying, then in this scenario also, if I choose to deny and player B denies, it's a 5-5. But if I choose to confess and the other person, player B, is denying, then my strategy becomes a 0. My payoff becomes a 0. So in both scenarios, whether player B confesses or whether player B denies, the best strategy for me is to confess. And the similar rationale can be worked out for player B as well. Player B will check, if I'm confessing, what is player A doing in both the scenarios? If I deny, what happens to A and B in both the scenarios? And in all of these circumstances, 60-60 becomes the best choice in comparison. And so it becomes a dominant strategy in this scenario. There are also weakly dominant strategies, strictly dominant strategies, a lot of all of these permutation combinations. And they're essentially whether, what if the scenario was a 60-60 for both deny, deny, and confess, confess, and you actually can't take a decision. So that's a weakly dominant strategy. A good way of understanding weakly dominant strategies are, how we did indifferent, and we did at least as preferred as. So an indifferent sign plus equation sign, that sort of stuff. So then that's essentially how you can think about a weakly dominant strategy in economic terms. So here is dominant strategy, and you can think about it even more, right? And I'll provide you with the video link for that YouTube series, and that will really help clear out things and why this is a dominant strategy, why there are strategies which are pure strategies. So all of this is very interesting, and all of this is about decision making. So this is the last class that we're doing on how what are decision making frameworks, ideologies, and assumptions in classical economics. From tomorrow we move on to our growth. I mean, we only have like 3 classes left now, and from tomorrow we'll be talking about behavioral economics and how it sort of ties all the knots together. And yet behavioral economics is not free from its own criticisms. So this entire platform is for you to question and to analyze if things are making sense. A zero sum game, we don't have the time to go in depth in it, but it's essentially that it's a plus one minus one in all scenarios. So if you are winning, the other person is naturally losing. And we can't solve zero sum games the way we solve Prisoner's Dilemma. So there's an entire literature again about the calculation that has to go into solving zero sum games. But I added on this because zero sum games is as a metaphor or as a quotation is also something that's very widely used while you're writing or something of that. Is it a zero sum game? If I win, do you have to lose? So, which is why it's interesting to know, and you can read up more on it. But the calculation is um, based on my understanding of the class, right? It's pretty much outside the purview of what we can discuss. All right, last questions to leave you with, right? Is game theory more realistic than the maximizing utility stuff we've done? Is it at least incorporating the behavioral aspects of people? The second thing is, what are problems in this theory? And this is where I want to bring up this idea of social factors and psychological factors. If you were friends, economics doesn't care about if you were friends, then you would have chosen to deny. Because economics would say that irrespective of what the other person is doing, you should confess. So are there caveats in this theory? Because in the real world, if I am in this scenario, I am judged and my decisions are based on all of these psychological factors. They're built on the context in which I'm working. They're built on the cultural and historical backgrounds I have. What if the other person was my brother? Would I still snitch? No. What happens when, let's say, because he's my brother, I choose to take I confess and he chooses to deny. And I would take that brunt because of the fact that I have to protect my brother. But economics would call me irrational in that scenario. So these are things to think about because we are not just economic agents. And those are questions I want to leave you with. The third thing is just simply what are other areas in which game theory can be used. And this is again your way of thinking about scenarios or real world situations and decision making where you think game theory might be used or might be useful in making better decisions. I gave you the example of a war scenario, to go to war or not go to war. The other scenario is if your competitors are increasing prices, should you increase prices? We've already discussed prisoner's dilemma. There are things like battle of the sexes, which is I want to go to a rom-com movie, but let's say my boyfriend wants to go into wants to watch an action thriller. This example is highly stereotypical. I don't promote this. But to give an example, right? I am choosing one thing A, the man wants to choose B. And then what do you do in that scenario? So that's again a payoff matrix. How do you make sure that you're doing one thing without making the other person unhappy? And so the video series lecture, the link that I gave you, actually has all of these games, and I'll break it down and explain things to you. So that's really, really cool if you found this class interesting and you want to explore things more in game theory, because it does help you build logical reasoning, right, and analytical skills. Now what you have to do as logical human beings is you take these learnings of strategic decision making, but you add in components of social and psychological factors, and then you take a decision that makes the most sense for you. That's that's basically it for today. If there are any questions, we can take that now.
Just have like one just basic question.
Mhm.
Since we studied about game theory today, I just are like investors invest in stock market, right? Does stock markets have this concept of game theory? Okay. I personally found this class really interesting. Thank you.
I'm so glad you're enjoying. Anyone else, if there's anything you guys want to talk about, mention resources for extra interesting things, all of that can be provided. Otherwise, see you guys tomorrow.
I found the class really interesting today. So I had just a one question. I know this field is really diverse, but like, what mathematical calculations do we use to predict decisions taken by consumers, and about whose psychological behavior we don't know? Obviously they will take up utility, but we describe this in form of mathematical calculations, but how we do so? Like, is there kind of like a formula kind of thing for this we do?
There's no one formula, Shwangi. There are different models that will give you different answers. And for Bye Shivani, thank you. And there are different models that will give you different answers, and the best way to go, because you're trying to model real life situations, right, which have uncertainty, which have risks involved. So what usually happens is you're compiling a lot of different models that will give you different answers, and then you build up from it. It's a very inductive form of reasoning.
Okay, got it. Thank you.
All right, thank you guys, thank you so much for the nice things. See you guys tomorrow.